Hey guys, today we are going to be writing models of exponential functions, okay? So what that looks like is this. Let's say I have y equals 78 times 1.35 raised to the t power. All right. So I want to know, is this a function of exponential growth or decay? Well, the way we know that, of what that is whatever is going on the inside of the parentheses. If this is more than 1, then we would say that it is a growth function, okay? If inside the parentheses it's more than 1, it is a growth function. But if the inside of the parentheses is less than 1, it is a decay function, okay? So let's say I have y equals 78 times 1 plus 0.46, all right? So they're going to ask, is this a growth or decay function? Also, they're going to ask, what is the initial amount? Also, what is the percent of increase or decrease? So we need to know first, is it a growth or a decay function? What is the initial amount? And what is the percent of increase or decrease? First off, I look to the inside of the parenthesis, and when I do the addition or subtraction on the inside of the parenthesis, I realize that this is 1 plus 0.46, so that's 1.46. And remember, if it's more than 1, it is a growth function. So this would be a growth function. The initial amount is whatever is outside of the parenthesis. So in this case, it would be 78. And in order to find the percent of increase, I need to know how far away is the number inside the parenthesis away from 1. In this case, it is 0.46 away from 1. It is a positive 0.46 away from 1. That means that it is an increase of 46%. So down here I will write 46%. And that's how you identify the parts of an exponential function. Let's do another. Here I have y equals 200 times 1 minus 0.06. Okay? So first I need to ask, is it a growth function or a decay function? Well, I need to do some arithmetic on the inside of my parenthesis. And when I punch that in a calculator, I'll do 1 minus 0.06, and that is 0.94. Well, that is less than 1. So it is a decay function. Next, I need to know my initial amount. So that is the number on the outside of the parenthesis. So my initial amount is 200. And now I need to know the percent of increase or decrease. Well, I need to know how far away 0.94 is away from 1. Well, here's a little trick. If you have 1 minus something or 1 plus something inside your parenthesis, that means that it is negative 0.06 away from 1. So this one would be decreasing, and 0.06 is 6%. So this one decreases by 6%. So here I have the function y equals 70 times 0.62 raised to the t power. And first I need to find out, is this a growth or a decay function? Well, you'll notice on the inside, this is less than 1. When it's less than 1, it is a decay function. Remember that. Less than 1 is a decay function when it's less than 1 on the inside of the parenthesis. We also need to know, what is the initial amount? Well, the initial amount is whatever is right outside the parenthesis. So our initial amount is 70. And now we need to find the increase or decrease. Remember, if it's decay, it's always going to be a decrease. You can't decay to an increase. It's always a decrease. So we know it is a decrease. All right, now we need to find out how far is 0.62 from 1. So I will do 1 minus 0.62, and my answer is 0.38. Now, 0.38, that is 38%. So my decrease is 38%. So here I have the function y equals 1,000 times 1.4 raised to the t power. So first thing I need to know, is this a growth or a decay function? Well, inside the parenthesis, that is greater than 1. So that means it is a growth function. We need to know the initial amount. So that's the amount right out in front of the parenthesis, and that will be 1,000. Now I need to know, how much does this increase or decrease? Well, we know it's a growth function. So with a growth function, we know that's going to be an increase. We just need to know, how much does it increase? So I will do 1. So I need to find out how far 1.4 is from 1. So I will do 1.4 minus 1, and the answer is 0.4. Now, you might think that that's 4%, but this is actually 0.40, which is 40%. So my increase is 40%. And that is how you model exponential functions. And you find whether it's a growth or a decay function, and how you find the initial amount, as well as the percentage of increase or decrease.